There is a place where nothing rushes, where time does not press against you, where there are no alarms, no deadlines, no lists of things left undone. It is not a place you have to travel to, not a destination you need to book or plan or prepare for. It is already all around you. Right now, as you lie there in the soft weight of your blankets, as your breath slows and your shoulders drop just a little closer to the mattress, you are already inside it. You are sitting on a small, quietly spinning rock, wrapped in a thin layer of air, tilted at just the right angle toward a star that has been burning steadily for 4.5 billion years without stopping. Beyond your ceiling, beyond the clouds, beyond the dark curve of the atmosphere, the solar system stretches out in every direction, vast and unhurried and breathtakingly, profoundly calm. Tonight we are going to drift through it together. We are going to visit each world in turn, starting close to the sun and moving slowly outward, past the rocky planets and the gas giants and the icy distant worlds at the edge of everything. We are going to linger on the details that are easy to miss, the beautiful, slow, quiet facts that get lost in the noise of ordinary days. There are no disasters here, no emergencies, no drama, only deep time and gentle orbits and the ancient, reliable rhythm of a solar system doing what it has always done, quietly and without any need for your attention. So settle in, let your body feel heavy, let the day fall away from you like a coat dropping off your shoulders. Wherever you are in the world tonight, whatever happened today, for now you are simply a passenger on a small blue world, moving through an enormous and peaceful darkness. And it is very, very beautiful out there.
Before we go any further, a small, quiet word from me to you. I have been working on this channel, Heyo Boring History for Sleep, for just over a year now. I pour a great deal of care into every single script, every recording, every video, trying to make something that genuinely helps people slow down and drift off. And right now, this channel has around 200 subscribers. 200, which I am deeply grateful for, truly. But my quiet dream is to reach 1,000. If these slow, gentle videos have ever helped you fall asleep, or eased a restless night, or simply given your mind something soft to settle on, it would mean the world to me if you liked this video and subscribed. It costs you nothing, and it helps more than you know. And now, without any further interruption, let us go back out into the dark, back to the solar system, back to the calm. Section 1. The Sun, a slow, ancient heartbeat. Let us begin at the center. There is a star at the heart of our solar system, and it has been burning for approximately 4.5 billion years. Say that number slowly, the way you might say something before sleep, the way you let the syllables dissolve. 4.5 billion years. A billion is already difficult to hold in the mind. 4.5 of them, measured not in seconds or minutes but in years, each one 365 days long, each day with a morning and a night, a sunrise and a sunset. The sun has presided over roughly 4.5 billion of those cycles,
and it has barely changed.
This is the first relaxing fact about the Sun. It is astonishingly stable. From a human perspective, the Sun simply does not change. It rose this morning, it will rise tomorrow. It rose on the morning your grandparents were born, and on the morning their grandparents were born, and on every morning stretching back through every civilization and every ice age and every era of life on this planet. Always the same Sun, always making its slow arc across the sky, always setting in the same general direction, always returning. No other force in human experience comes close to that level of consistency. The Sun is the one thing that has never, in the entire span of human existence, failed to come back. Scientifically, the Sun is a main sequence star, which means it is in the long, quiet middle portion of its life. It is not young and turbulent, not old and swelling. It is in what astronomers call its stable burning phase, fusing hydrogen into helium in its core at a rate that is, by cosmic standards, beautifully relaxed and steady. Every second, the Sun converts around 600 million tons of hydrogen into helium. That sounds like a great deal of activity, but consider that the Sun contains enough hydrogen to sustain this process for another 5 billion years. 5 billion. It is not running out. It is not even close to running out. It is a fire with a fuel supply so vast that from where we stand, it might as well be infinite. The Sun is enormous, of course. So enormous that if you hollowed it out and tried to fill it with Earths, you could fit roughly 1,300,000 of them inside. But enormity and calm are not mutually exclusive. Think of the ocean. Think of a mountain. The very largest things tend to have a certain quietness about them, a stillness that comes from sheer scale. The Sun is like that. Its gravity is so immense that it holds everything, every planet, every moon, every comet and asteroid and drifting fragment of rock and ice across a distance of roughly 2 light-years in every direction, all of it held in a gentle, invisible embrace. Nothing escapes, nothing needs to escape. Everything simply orbits, round and round, steady and dependable, the way a mobile over a crib turns slowly in the draught from an open window. The surface of the Sun is approximately 5,500 degrees Celsius. This is, admittedly, not the kind of temperature that invites relaxation in a conventional sense. But consider what that heat means at our distance, 93 million miles away. It arrives here as the warmth on your face on an autumn afternoon. It arrives as the light through your curtains in the early morning, that particular gold that filters through fabric and falls across the floor in soft rectangles. All that warmth, all that light, all that energy, traveling for 8 minutes and 20 seconds across the vacuum of space and arriving gently, diffused and softened by the atmosphere, as something that makes you close your eyes and tilt your face upward. The Sun also breathes, in a manner of speaking. It produces what is called the solar wind, a continuous stream of charged particles that flow outward in all directions at speeds of several hundred kilometers per second. The solar wind fills the entire solar system, pushing outward in every direction, like the slow exhalation of something enormous. It is this solar wind that gives comets their tails, always pointing away from the Sun, regardless of which direction the comet is traveling, the way a flag always streams away from the wind. It is this same wind that creates the auroras, the northern and southern lights, those slow green and violet curtains that ripple across the polar skies on quiet winter nights. The solar wind arrives at Earth.
is deflected and shaped by our magnetic field, and in the regions near the poles, it spirals down into the upper atmosphere and creates light. Light made from breath. There is something worth holding in your mind about the scale of the sun's influence. The solar wind does not stop at Earth, or at Mars, or even at Jupiter or Saturn. It keeps flowing outward, thinning as it goes, all the way to a boundary called the heliopause, which lies roughly 11 billion miles from the Sun. Everything inside that boundary, every planet and moon and rock and gas cloud, exists within the Sun's atmosphere. We do not live on a planet near a star. We live inside a star's outermost, most gossamer layer, so thin and diffuse that we cannot feel it or see it, but there all the same. The Sun surrounds us, has always surrounded us, and it does so quietly, without asking anything in return, without drama, without interruption.
In roughly 5 billion years, the Sun will begin to change. It will swell into what is called a red giant, expanding outward, growing cooler and redder and enormous. But this is so far in the future that it has no practical meaning for anything alive today. It is as irrelevant to your life as the thoughts of someone who will not be born for 10,000 generations. For every purpose that matters, the Sun is permanent. It is the fixed point, the heartbeat at the center of everything. And right now, even as you read or listen to this, the Sun is on the other side of the Earth from you. Your side of the world is in darkness, turned gently away, resting in the cool quiet of night. The Sun is still there. It has not gone anywhere. It is waiting patiently for morning, as it always does, as it has for 4.5 billion years, and will continue to do for 5 billion more. That is not a frightening thought. That is one of the most reassuring thoughts in the universe. And here is another thing worth knowing about the Sun, something that very few people pause to think about. The light that leaves the Sun's surface takes about 8 minutes and 20 seconds to reach Earth. But the light itself, the specific photons of energy, began their journey much earlier than that. Deep inside the Sun, in the core where nuclear fusion takes place, energy is produced as high-energy gamma rays. But the Sun's interior is so incredibly dense that these photons do not travel freely. They are continuously absorbed and re-emitted by the particles around them, bouncing from one point to the next in a random walk through the solar material. This process, called radiative diffusion, is extraordinarily slow. By some estimates, a photon of energy produced in the Sun's core may take anywhere from 10,000 to 170,000 years to make its way from the center to the surface. The exact number depends on how you define the photon's journey, given that the energy is being absorbed and re-emitted repeatedly, rather than a single particle traveling the whole way. But in any case, the energy that left the Sun's surface this morning began its journey inside the Sun long before the pyramids were built. The warmth on your skin on a sunny afternoon is the product of a process that started in the deep interior of the Sun thousands or perhaps hundreds of thousands of years ago, working its way patiently outward through layer after layer of dense solar material, until it finally reached the surface and was released as the light that crossed 93 million miles of space in just over 8 minutes to reach you. Light that is older than civilization, arriving as the warmth of a morning. There is something in that which invites a kind of quiet gratitude. Section 2. Mercury, the forgotten little world. Mercury is the smallest planet and the closest to the Sun, and it is also, in some strange and lovely way, one of the most overlooked. It does not have the romance of Mars or the dramatic beauty of Saturn. It has no moons, no rings, no atmosphere to speak of. It is a small, dense, heavily cratered ball of rock that orbits the Sun in just 88 Earth days, racing around the inner solar system in a tight elliptical path, and almost nobody thinks about it very much. This, I think, is precisely what makes it worth thinking about. Mercury moves fast in its orbit, faster than any other planet. But here is the wonderful contradiction. Mercury also rotates incredibly slowly on its own axis. In fact, Mercury rotates so slowly that one Mercurian day lasts approximately 59 Earth days. And because of the complicated relationship between its orbital speed and its rotation rate, if you were standing on Mercury's surface, the time between one sunrise and the next would be approximately 176 Earth days. Think about that for a moment. A single day, measured from sunrise to sunrise, would last nearly 6 of our months. The Sun would crawl across the sky with aching geological slowness. Hours would pass, and it would barely seem to move. There is something deeply restful about that idea. Time moving at an entirely different pace. The Sun hanging in the black sky, barely changing position, while the shadows shift imperceptibly across the cratered plains.
Mercury has no atmosphere in any meaningful sense. There are trace amounts of gases clinging to its surface, mostly atoms of oxygen, sodium, hydrogen, and helium that have been liberated from the surface rocks by the solar wind and by micrometeorite impacts. But this is not an atmosphere the way we think of an atmosphere. There is no wind on Mercury. There is no weather. There are no clouds. The sky above Mercury's surface is simply black, even during the day, because there is no air to scatter the sunlight. If you were standing on Mercury's surface, you could look directly overhead in the daytime and see stars, crisp and unblinking in the black, while below your feet the ground was baking at 430 degrees Celsius. And yet, just a few kilometers away, in the west direction, in the permanently shadowed craters near Mercury's poles, the temperature never rises above minus 180 degrees Celsius. Scientists have confirmed that Mercury, despite being the closest planet to the Sun, harbors ice, water ice, sitting in the eternal shadow of deep crater walls, preserved for billions of years in one of the most extreme environments in the solar system. There is something quietly poetic about that. The hottest daytime temperatures in the inner solar system, and frozen water hiding in the shadows, patient and undisturbed, having sat in those craters for perhaps billions of years without anyone knowing.
Mercury's surface is ancient. Unlike Earth, which is constantly reshaped by plate tectonics and erosion and biology, Mercury's surface is a largely unchanged record of the early solar system. Most of the craters we see on Mercury were formed during a period called the Late Heavy Bombardment, roughly 3.8 billion years ago, when the inner solar system was being pelted by debris left over from the formation of the planets. The scars of that bombardment are still there, perfectly preserved, their edges sharp
and clear, because nothing has happened since to soften them. Mercury's surface is like a photograph taken 4 billion years ago and never disturbed. There is a particular feature on Mercury called the Caloris Basin. It is a vast impact crater, roughly 1,500 kilometers across, formed when an enormous asteroid struck Mercury early in its history. The impact was so powerful that it sent shockwaves through the entire planet, and on the exact opposite side of Mercury from the impact point, those shockwaves met and concentrated, buckling and distorting the surface into a strange, tumbled landscape called the chaotic terrain. A single event, billions of years ago, echoing all the way through a planet and leaving its mark on the other side. The universe remembers things for an extraordinarily long time.
Mercury was visited by Mariner 10 in the 1970s, and later by the Messenger spacecraft, which orbited Mercury between 2011 and 2015. Messenger revealed a world of extraordinary variety despite Mercury's small size. There are plains of ancient volcanic rock. There are towering cliffs called scarps, some of them hundreds of kilometers long and up to 3 kilometers high, formed as Mercury's interior slowly cooled and contracted over billions of years, causing the crust to wrinkle and buckle like the skin of a slowly drying fruit. These cliffs are still there, undisturbed, as crisp and clean as the day they formed. Mercury also has an unexpected magnetic field. Scientists had not expected a planet so small to have maintained a magnetic field this far into its life. Mars, for example, long ago lost its magnetic field as its interior cooled. But Mercury still has one, weak but real, as though something in its deep iron core is still faintly alive. The solar wind interacts with this magnetic field and occasionally produces dramatic auroras in Mercury's thin exosphere. Auroras on Mercury, on a world most people never think about. Colours in the sky above a barren and ancient landscape that no one has ever stood on. Mercury orbits the Sun at an average distance of about 58 million kilometers, roughly 35% of the Earth's sun distance. From Mercury, the Sun would look about 3 times as large in the sky as it does from Earth. Enormous, hanging there in the black, blazing and beautiful and close.
And yet Mercury persists, small and unregarded and ancient, orbiting faithfully, cratered plains turned toward the dark, ice sitting quietly in the shadows. There is something peaceful about forgotten things, something restful about a world that asks for no attention, that simply does what it does, turn by turn around the Sun, steady and unhurried, the same today as it was 4 billion years ago.
Venus is wrapped in clouds. Not thin, wispy clouds like the ones that drift across our sky, but a permanent, planet-wide layer of thick cloud composed primarily of sulfuric acid droplets that completely hides the surface from view. From space, Venus appears as a brilliant, featureless white disk, the brightest object in the night sky after the moon. It reflects about 70% of the sunlight that strikes it, a perfect mirror surface that glows in the evening and morning sky like a steady white lamp. Ancient astronomers called it the morning star and the evening star before they understood it was a single object. And for thousands of years it was one of the most reliable guides in the night sky, a fixed point of brightness that sailors and travelers could count on. Beneath those clouds, the surface of Venus is an alien landscape of ancient volcanic plains, enormous shield volcanoes, and highlands that rise above the cloud base. The atmospheric pressure on Venus's surface is about 92 times the pressure on Earth's surface at sea level. It is roughly equivalent to the pressure you would feel if you were about 900 meters underwater. The temperature is approximately 465 degrees Celsius, hot enough to melt lead, and this temperature barely varies between day and night or between the poles and the equator, because the thick atmosphere distributes heat so efficiently that the entire planet is essentially the same temperature everywhere. A kind of terrible, crushing uniformity. And yet, there is beauty here too, viewed from a safe distance.
The clouds of Venus, when imaged in ultraviolet light, reveal extraordinary patterns. Dark streaks and swirling formations, vast atmospheric waves, thousands of kilometers long, all moving slowly in the upper atmosphere. The winds at cloud level reach speeds of around 300 kilometers per hour, fast enough to carry the cloud patterns all the way round the planet in about 4 Earth days. So while the surface below rotates with agonizing slowness, the clouds above race around the planet in a perpetual gale. Venus is 2 worlds occupying the same space, a slow, hot, ancient surface, and a fast, turbulent sky. Venus may have been habitable in the distant past. Some planetary scientists believe that billions of years ago, before its runaway greenhouse effect took hold, Venus had liquid water oceans and a climate that was not entirely unlike Earth's. If that is true, then there was a window, perhaps hundreds of millions of years long, when Venus was a blue and green world, with seas and perhaps even complex chemistry. We do not know what happened on its surface during those years, because the evidence has been buried under billions of years of volcanic resurfacing. Venus's surface is geologically young in planetary terms, mostly between 300 million and 500 million years old, which suggests that at some point in the planet's past, a catastrophic global volcanic event repaved the entire surface, like pressing reset on a very large scale.
There are nearly 2,000 identified volcanoes on Venus, more volcanoes than on any other planet in the solar system. Most are thought to be dormant, but in recent years, researchers analyzing data from the Magellan spacecraft have found evidence that at least some may still be active. A world of volcanoes wrapped in sulfuric acid clouds, spinning slowly backward under a sky that never clears. It is strange and extreme and entirely its own thing. And it has been doing this quietly and without any particular need for observation for 4.5 billion years. There is something almost meditative about Venus's pace, the extraordinary slowness of its rotation, the way its clouds circle endlessly above a surface that barely changes from year to year, the way it glows in our sky, steady and bright, a world of enormous forces that from a distance look simply like a light, calm and permanent,
and quietly, immovably there. Section 4. Earth from the outside, our pale blue dot. On February 14th, 1990, as the Voyager 1 spacecraft was racing away from the solar system at a distance of roughly 6 billion kilometers from Earth, mission controllers sent a command to the spacecraft to turn its camera around and point it back toward the Sun. The result was a sequence of images, later assembled into a mosaic known as the family portrait, showing the Sun and 6 of the planets hanging in the darkness. And in one of those images, barely visible against the scattered light from the camera lens, was a tiny, faint point of pale bluish white. That point was Earth.
Carl Sagan, who had advocated for taking the photograph, wrote about it in a way that has never quite been equaled. He described the pale blue dot as a very small stage in a vast cosmic arena, noted that every human being who had ever lived had lived out their lives on that mote of dust suspended in a sunbeam, that every king and peasant, every young couple in love, every mother and father, every inventor and explorer and saint and sinner, every teacher of morals and every corrupt politician, every superstar, every supreme leader, every hero and coward in the history of the human race had lived there, on that tiny point of light, barely distinguishable from the background darkness of space. It is impossible to look at that photograph and not feel something that is not quite sadness and not quite awe, but some mixture of the two, softened by wonder. The Earth is so small, the universe is so large, and yet here we are, alive on this particular speck, which happens to have exactly the right conditions for things like you and me, and trees and oceans, and late nights spent reading about planets. From space, Earth is predominantly blue. About 71% of the surface is covered by ocean, and from a sufficient distance, this gives the planet a deep, brilliant blue color, unlike anything else in the solar system. The land masses are visible as brown and green patches, but they are the minority. Earth is primarily a water world, a smooth sphere of blue wrapped in wisps of white cloud that curl and drift and reorganize constantly, never the same twice. The first astronauts to see Earth from space described being overwhelmed by it, by its color, by its brightness, by the impossibly thin line of the atmosphere visible along the edge of the disk, a faint blue haze so fragile-looking that many of them said they immediately understood, in a way they had never understood before, how precious and delicate this thin layer of gas was. The atmosphere, seen from space, is just a thin blue line. All the air we breathe, all the weather, all the clouds and winds and storms, compressed into a layer so thin that if you scaled the Earth down to the size of a basketball, the atmosphere would be thinner than a piece of paper. It is everything, and it is barely there. There is a phenomenon that astronauts describe called the overview effect. It happens when they look at Earth from the perspective of space and experience a sudden, profound shift in perception. The borders between countries disappear. The arguments and divisions and conflicts that seem so enormous from the inside become invisible. What remains is simply the planet, whole and undivided, floating in the dark. Many astronauts report feeling a sense of deep, unexpected calm, a feeling of connection and perspective that stays with them for the rest of their lives. Some have described it as the most important thing that ever happened to them. Earth is the densest planet in the solar system. It is also the only one with plate tectonics actively reshaping its surface,
the only one with a large moon in a stabilizing relationship with its axial tilt, and the only one we know of with life. The moon is unusually large for a planetary satellite. Most moons are tiny compared to their host planet. Our moon is more than a quarter of Earth's diameter, a companion so substantial that some scientists prefer to call the Earth-Moon system a double planet rather than a planet and its satellite.
There is something worth lingering on about the specific conditions that make Earth habitable. It is not simply that Earth is at the right distance from the Sun, though it is. It is not simply that Earth has water, though it does, in enormous and beautiful abundance. It is the combination of factors, the delicate layering of conditions, each one necessary, each one dependent on the others. The carbon cycle, which transfers carbon between the atmosphere, the oceans, and the rocks, acts as a long-term thermostat. When the climate warms, more carbon dioxide is absorbed by weathering of rocks and by the ocean, cooling the planet again. When the climate cools, volcanic activity releases carbon dioxide, warming it. This cycle operates over millions of years, slowly and gently, like a thermostat in a very large house. It has kept Earth's temperature within the range required for liquid water for most of the last 4 billion years, through ice ages and warm periods, through the brightening of the sun and the drifting of the continents. The Earth regulates itself, not perfectly, not always gently, but effectively over the long run.
The biosphere, the sum total of all life on Earth, also participates in regulating the planet. Photosynthesis removed carbon dioxide from the early atmosphere and replaced it with oxygen, fundamentally transforming the planet's chemistry over the course of roughly 2 billion years. The organisms that did this, ancient cyanobacteria, were not trying to change the world. They were simply living, processing sunlight and carbon dioxide into sugars and releasing oxygen as a byproduct. And over billions of years, that byproduct accumulated, filling the atmosphere, creating the conditions for every complex life form that followed, including you. Life changed Earth, and Earth changed life in a long, slow, unplanned partnership that is still ongoing. Right now, in every cubic centimeter of the ocean surface, there are millions of microscopic organisms converting sunlight and carbon dioxide into the organic matter that forms the base of almost every marine food web. In every gram of healthy soil, there are billions of bacteria breaking down organic material, releasing nutrients, maintaining the chemistry of the ground. The Earth is not a passive backdrop for life. It is alive at every scale, from the microbial to the geological. And all of this, every microbe and mountain and ocean and cloud, exists on that pale blue dot. That single pixel of reflected sunlight visible from 6 billion kilometers away.
The Earth rotates once every 23 hours, 56 minutes, and 4 seconds. This is called a sidereal day, the time it takes for Earth to complete one full rotation relative to the distant stars. The solar day, the time from noon to noon, is slightly longer, at 24 hours, because Earth has also moved a little along its orbit during that rotation, and needs to rotate just a fraction more to catch up with the Sun. These 23 hours and 56 minutes, this particular rhythm, this particular length of day, is the beat that all of life on Earth has evolved around. Your circadian rhythm, the biological clock that tells you when to sleep and when to wake, is tuned to this exact frequency. You are synchronized, body and biology, with the rotation of the planet. Right now,
Earth is tilted at about 23.5 degrees relative to its orbital plane. This tilt is what gives us seasons. It has been maintained at roughly this angle for hundreds of millions of years, stabilized by the gravitational influence of the Moon. Without the Moon, Earth's tilt would wobble chaotically over time, swinging from nearly 0 degrees to perhaps 85 degrees over millions of years. This would cause extreme planet-wide climate shifts. The Moon's gravitational steadiness is part of what makes Earth's climate livable, part of what made life possible. From 63,000 kilometers above the surface, you can see the entire disk of the Earth at once. From 35 million kilometers away, it appears as a bright star. From 6 billion kilometers away, it is a pale blue dot, barely visible, a single pixel of reflected light against the dark.
And down there, inside that pixel, you are lying in your bed, warm and safe, on a spinning rock that has been perfectly calibrated for your existence. There is no word for how improbable that is. There is no word for how beautiful it is. But it is there, quietly and reliably, holding you while you sleep.
Since its formation, the Moon has been slowly moving away from Earth. When the Moon first formed, it was perhaps 20,000 kilometers away, close enough that it would have appeared 10 or 15 times larger in the sky than it does today. Over billions of years, tidal interactions between the Earth and the Moon have gradually transferred angular momentum, pushing the Moon outward. Today, the Moon is approximately 384,000 kilometers away, and it is moving away from us at a rate of about 3.8 centimeters per year, roughly the speed at which your fingernails grow. 3.8 centimeters per year. The Moon is retreating from us so slowly that you would need the most precise instruments ever built to detect it happening. From a human perspective, the Moon is simply always the same distance away. But it is moving, has always been moving, will continue moving for as long as the Earth and Moon exist together, drifting apart with the patience of deep time. The Moon is tidally locked to Earth, which means it always shows us the same face. The same side, the one with the Mare Tranquillitatis and the Mare Serenitatis, and the broad plains of ancient lava that early astronomers called seas because they looked smooth and dark from Earth, always faces us. The far side of the Moon, which is more heavily cratered and has less of the flat dark plains, was completely unknown until spacecraft first flew around and photographed it in 1959. The near side has been a constant in the human sky for as long as our species has existed. The same craters, the same shadows, the same arrangement of light and dark, looking down every night from its position in the sky.
Many cultures have seen faces in the Moon. The man in the Moon, visible in many traditions, is formed by the pattern of the dark mare regions, the flat ancient plains. Others see a rabbit, a woman, a toad, The human mind, trained by evolution to find faces and patterns, has been finding them in the moon for hundreds of thousands of years. Before agriculture, before cities, before writing, our ancestors looked up at the same moon and found shapes in it. The moon has been a companion for the entire length of human experience. The surface of the moon is covered in a layer called regolith, a fine powder of broken rock and glass formed by billions of years of micrometeorite impacts. The regolith is several meters deep in most places, a soft grey blanket over the ancient rock beneath. When the Apollo astronauts walked on the moon, their boots sank slightly into this fine powder, leaving footprints with crisp, sharp edges. Because there is no wind on the moon and no water, and because the moon has no geological activity to erase them, those footprints are still there. The boot prints of 12 human beings, left between 1969 and 1972, are sitting in the lunar dust right now, waiting, unchanged, in the silence.
The moon has no atmosphere, no weather, almost no internal heat. Its surface temperature swings from about 127 degrees Celsius in the day to minus 173 degrees at night, a range of 300 degrees that happens over the course of a lunar day. But these swings happen slowly, over 2 weeks of daylight and 2 weeks of darkness, because the moon rotates so slowly, at the same pace it orbits Earth. The heat arrives gradually and departs gradually, like a tide. The moon's gravity pulls on Earth's oceans, creating the tides. Twice a day, in most coastal places, the sea rises and falls in response to the moon's pull, and to a lesser extent the sun's. This has been happening for billions of years. The tides are ancient and regular, a rhythm that preceded all complex life on Earth. The tidal zones created by these rhythmic risings and fallings may have played an important role in the development of life, creating areas where organic chemistry could concentrate, dry out, get wet again, and experiment with increasingly complex forms. The moon may, in this sense, be partially responsible for our existence. At night, when the moon is full, it reflects enough sunlight to cast shadows. You can read by full moonlight in open country. The light is pale and silver and cool, nothing like sunlight, but enough to navigate by, enough to see the outline of trees and buildings and roads. Before electric lights, the full moon was a significant and practical event. Farmers could work by moonlight, travelers could move at night. The moon was a lamp, borrowed from the sun and returned again as it waned. Tonight the moon is somewhere above you, even if you cannot see it. Perhaps on the other side of the Earth, perhaps hidden behind clouds. It is always there, a little less than 400,000 kilometers away, faithful and quiet, pulling softly on the oceans, throwing back a little of the sun's light, drifting away from us at the rate of a fingernail's growth, patient and permanent and ours. There is one more thing about the moon that deserves to be said slowly and allowed to settle. The moon has no wind, no weather, no erosion from rain or rivers. Its surface changes only through impacts and the very gradual effects of temperature cycling. This means that the moon is, in a very real sense, a museum of the early solar system, of ancient impacts, of the history of the inner solar system stretching back 4 billion years. Every crater on the moon is a record of something that happened. A small rock
or a large one, traveling through space and striking the surface, and that moment preserved forever in the shape of the land. The moon cannot forget. Nothing wears away, nothing fills in. The craters simply sit there, in the silence, holding the record of their own creation, waiting for someone to read them.
When geologists study the ages of different regions of the moon, they count the density of craters. More craters means an older surface that has had more time to accumulate impacts. Fewer craters means a younger surface that formed more recently. By counting craters, scientists can read the moon's history, dating different regions to different eras of the early solar system. The dark plains, the maria, formed when enormous ancient impacts fractured the crust and allowed lava to flow up and flood vast areas of the surface. This happened roughly 3 billion years ago, give or take. The lava cooled and solidified and has been there, quiet and dark, ever since. 3 billion years of quiet. 3 billion years of the same dark plane sitting in the same place under the same airless sky, lit by the same sun, looking back at the same Earth. And down here on that Earth, things have been considerably busier.
The light on Mars is something that no human has ever seen with their own eyes, but we have photographs. Photographs taken by the rovers and landers that have spent years on the Martian surface. And the light looks wrong, in the way that only slightly wrong things can look wrong, familiar enough to recognize, but subtly alien. The sky on Mars is not blue. It is a butterscotch color in the daytime, pinkish tan, the result of fine iron-rich dust suspended in the thin atmosphere. Sunsets on Mars are blue, the opposite of Earth's sunsets. Where our evenings turn gold and orange and red, Martian evenings turn blue around the sun, a soft, cold blue spreading outward across the tan sky as the sun descends. Mars has the most extreme terrain in the inner solar system. It has the largest volcano, the longest canyon, some of the oldest exposed rock surfaces, and at the same time some of the highest clouds. It is a world of superlatives wrapped in silence and dust. The volcano is called Olympus Mons. It is approximately 22 kilometers high from base to summit, roughly 2.5 times the height of Mount Everest measured from sea level. Its base covers an area approximately the size of the state of Arizona, roughly 600 kilometers across. If you were standing at its foot and looking up, you would not be able to see the summit. It would be over the horizon. Olympus Mons is so large that it is not possible to perceive its scale from ground level. You would need to be in orbit to see it whole.
And Olympus Mons is quiet. It formed over a period of billions of years, built up by countless eruptions of relatively fluid lava that flowed slowly outward from the central vent and accumulated over time, layer upon layer, building upward with geological patience. Unlike Earth's volcanoes, which are constantly being shifted around by plate tectonics, eventually moving off the volcanic hotspot that fuels them, Mars has no tectonic plates. The crust is stationary. So the hotspot beneath Olympus Mons has been pumping lava into the same place for billions of years, building the volcano taller and taller without interruption. The most recent lava flows on its flanks are estimated to be between 2 million and 115 million years old, which in geological terms is recent. Olympus Mons may not be entirely dead. Mars also has Valles Marinaris, a
Canyon system that stretches nearly 4,000 kilometers across the surface of Mars, roughly the width of the United States. In places, it is 700 kilometers wide and 10 kilometers deep. The Grand Canyon on Earth is about 446 kilometers long and about 1.5 kilometers deep. Valles Marineris is by comparison almost incomprehensibly large, a scar across the face of the planet so immense that it would not fit on most maps of Mars without considerable reduction.
Valles Marineris formed primarily through tectonic stretching and rifting, the Martian crust being pulled apart over billions of years. Unlike the Grand Canyon, it was not carved by water, though water may have flowed through parts of it in Mars's ancient past. It sits there now, quiet and enormous, its walls kilometers high, its floor covered in layered sediments and ancient landslide debris. The silence inside Valles Marineris must be absolute. There is almost no wind in its depths. There is no water. There are no birds or insects or leaves, just rock and dust and the thin, cold air, and above, a butterscotch sky. Mars has 2 tiny moons, Phobos and Deimos. They are not round the way large moons tend to be. They are potato-shaped, irregular, more like captured asteroids than proper moons. Phobos, the larger of the two, orbits Mars so closely that it completes an orbit in just 7.5 hours, faster than Mars rotates. From the surface of Mars, Phobos would appear to rise in the west and set in the east, sweeping across the sky twice a day in the wrong direction. Phobos is also slowly spiraling inward. It is losing altitude at a rate of about 1.8 meters per 100 years. In roughly 50 million years, Phobos will either crash into Mars or be torn apart by tidal forces into a ring of debris, the first ring Mars has ever had. The planet is unhurried even in its future catastrophes. 50 million years is a long time to wait for anything.
Mars has seasons, like Earth, because it is tilted on its axis at about 25 degrees, close to Earth's axial tilt of 23.5. The seasons are longer because the Martian year is about 687 Earth days. The winters in the Martian polar regions are cold enough to freeze carbon dioxide out of the atmosphere, which accumulates as dry ice at the poles. When spring comes, this carbon dioxide sublimates back into gas, creating jets of material that burst through the surface and carry dark dust onto the surface of the polar ice cap, painting it with dark spots and streaks. The poles breathe in and out with the seasons, expanding and contracting, exchanging material with the atmosphere on a vast, slow cycle.
Between the orbits of Mars and Jupiter, there is a region of the solar system that popular culture has for decades depicted as a dense field of tumbling rocks, a chaotic obstacle course that spacecraft must dodge and weave through at constant risk of collision. Films and television shows have given us images of ships threading their way through vast clouds of boulders, rocks of all sizes spinning and grinding against each other in some cosmic game of bumper cars. This is not even remotely accurate. The asteroid belt is, by the overwhelming measure of its actual volume, almost completely empty.
the total mass of all the asteroids in the belt combined is less than 4% of the mass of Earth's moon. All the rocks, all the metal, all the carbonaceous material, everything in the belt added together would make an object smaller than the moon. And this mass is spread across an enormous region of space. The belt extends from roughly 2.2 to 3.2 astronomical units from the Sun, a region so vast that the average distance between any two asteroid belt objects is roughly 1,000,000 kilometers. If you were traveling through the asteroid belt in a spacecraft, the chance of coming within 1,000,000 kilometers of any substantial asteroid would be relatively low, and the chance of a collision would be almost negligible. Both Voyager and Pioneer missions traveled through the asteroid belt without incident and without requiring any special evasive maneuvering. The asteroid belt is a wilderness of quietness and space. The largest object in the belt is Ceres, which is also classified as a dwarf planet. Ceres is roughly 945 kilometers in diameter, a small, rounded world that contains about a third of the total mass of the entire asteroid belt. It has a very thin atmosphere of water vapor detected by the Herschel Space Telescope. It has a surface of mixed rock and ice. The Dawn spacecraft, which orbited Ceres from 2015 to 2018, discovered something unexpected: bright white spots on the floor of a crater called Ocata. These spots, later identified as deposits of sodium carbonate and other salts, are among the most reflective natural features found in the inner solar system. Bright white patches on the floor of a dark crater on a small, cold world in the belt, glowing like fallen stars. The asteroids of the belt are thought to be the remnants of the early solar system, material that never successfully coalesced into a planet. The conventional explanation for why this region never formed a planet is Jupiter. Jupiter's powerful gravity created gravitational resonances in the belt region that prevented the rocks and metal there from clumping together. Every time material began to gather into larger bodies, Jupiter's gravitational influence stirred the pot, increasing orbital velocities and causing collisions that shattered objects rather than building them. The belt is, in this sense, a monument to Jupiter's dominance, a graveyard of would-be planet material that never got the chance.
The asteroids vary enormously in composition. Some are rocky, silicate-rich bodies, similar in composition to the rocky planets. Some are metallic, consisting primarily of iron and nickel, thought to be the cause of ancient protoplanets that were shattered by collisions long ago. And some are carbonaceous, dark and rich in organic molecules and water, among the most pristine material in the solar system. Some of these carbonaceous asteroids contain amino acids, the building blocks of proteins, organic chemistry, the chemistry of life, distributed through the belt in ancient rocks. There are also the Trojan asteroids, groups of small bodies that share orbits with Jupiter, sitting in stable gravitational positions about 60 degrees ahead of and behind Jupiter in its orbit. These are not in the main belt, but are captured companions to Jupiter, following the giant planet faithfully around the Sun, year after year, century after century, neither falling inward nor drifting away, locked in gravitational balance like slow satellites. Far out beyond the belt and distinct from it, there are other concentrations of small bodies, the Kuiper belt, which we will visit later, and the diffuse Oort cloud at the very edge of the solar system. But the main belt between Mars and Jupiter is the one most people mean when they say asteroid belt,
and it is worth pausing to appreciate how different it is from its reputation. Not a chaotic maze, but an open, quiet, almost empty wilderness, where ancient rocks drift in solitude, separated by distances so enormous that most of them have never come close to another asteroid, and never will.
There is something deeply calming about that image. A rock that has been drifting slowly and alone through an enormous region of empty space for 4.5 billion years, orbiting the sun in its gentle ellipse, undisturbed, unwitnessed, patient beyond any patience we have words for. There are also families of asteroids in the belt, groups of objects with similar orbits and similar compositions, thought to be the remains of larger bodies that were broken apart by ancient collisions. The Vesta family, for example, consists of fragments of the asteroid Vesta, the second largest object in the belt, and one of the few large asteroids to have differentiated, meaning it separated into a crust, mantle, and iron core, much like the rocky planets. Vesta was struck by an enormous impact roughly 1 billion years ago that created a crater so large it nearly destroyed the entire asteroid. Material blasted from Vesta's surface scattered across the solar system, and some of it eventually fell to Earth as meteorites. Those Vesta meteorites, now sitting in museum display cases and research laboratories on Earth, are pieces of the same object as the asteroid currently drifting in the belt, fragments of a body that was struck 1 billion years ago, making the long journey as rocky debris through interplanetary space for millions of years before falling through the atmosphere as glowing streaks in the night sky.
The meteorites that fall to Earth are mostly from the asteroid belt. They are the most common extraterrestrial material available for scientific study. Researchers have analyzed them in extraordinary detail, measuring their chemical compositions, their isotopic ratios, their crystalline structures, their ages. The oldest meteorites are among the oldest datable material in existence, some of them containing microscopic grains that formed even before the solar system existed, in the outflows of dying stars in other parts of the galaxy. These pre-solar grains are older than the Sun. They predate the formation of Earth by billions of years. They drifted through interstellar space, were swept up by the cloud of gas and dust that eventually formed our solar system, and ended up incorporated into the earliest asteroids. They traveled through the belt for billions of years before finding their way to Earth. You can hold a piece of the belt in your hand. You can hold something 4.5 billion years old. You can hold a piece of the solar system's very beginning, the original building material from which every planet, every moon, every living thing was eventually assembled. The belt is not just a collection of rocks, it is an archive, a deep library of the solar system's origins, written in stone and metal, patient and silent in the dark between the worlds. Section 8. Jupiter, a giant that hums.
Jupiter is the largest planet in the solar system by a considerable margin. It is so large that all the other planets combined, every single one of them, could fit inside Jupiter with room to spare. Its diameter at the equator is approximately 142,000 kilometers, more than 11 times the diameter of Earth. Its mass is 2.5 times the mass of all the other planets combined. Jupiter is not just the largest planet, it is in a real sense the defining feature of the outer solar system. Everything else orbits in relationship to Jupiter's gravity. And yet, Jupiter is made of almost nothing you could stand on.
Jupiter has no solid surface. It is a gas giant, composed predominantly of hydrogen and helium, with trace amounts of methane, water vapor, ammonia, and other compounds. As you descend into Jupiter's atmosphere, the pressure increases, and the hydrogen gradually transitions from gas to liquid. But there is no sharp boundary, no moment where you would land on something solid. The hydrogen simply gets denser and denser as you go deeper. Far down inside Jupiter, the pressure is so enormous that the hydrogen enters a strange state called metallic hydrogen, where the electrons are freed from their atoms and the hydrogen conducts electricity like a metal. This metallic hydrogen, churned by Jupiter's rapid rotation, is thought to be the source of Jupiter's powerful magnetic field, the strongest of any planet in the solar system.
Jupiter rotates once every 9 hours and 56 minutes, the shortest day of any planet. Despite its enormous size, it completes a full rotation in under 10 hours, which means the equatorial regions of Jupiter are moving at a speed of approximately 45,000 kilometers per hour relative to the axis. This rapid rotation causes Jupiter to bulge noticeably at the equator, making it visibly flattened rather than perfectly spherical. Even in a small telescope, the oblateness of Jupiter is apparent. The surface we see when we look at Jupiter is actually the tops of cloud layers, bands of different colored clouds circling the planet in alternating light and dark stripes. The lighter bands, called zones, are regions of rising gas. The darker bands, called belts, are regions of sinking gas. Between these bands, the wind shear creates enormous cyclonic storms. The colors come from chemical compounds, ammonias and sulfur compounds, and phosphine, reacting in Jupiter's atmosphere at different depths and temperatures. And then there is the Great Red Spot. The Great Red Spot is a storm, an anticyclone specifically, a region of high pressure that has been rotating counterclockwise in Jupiter's atmosphere continuously for as long as humans have been able to observe it. The earliest definitive observations of it date to the 17th century, making the Great Red Spot at least 350 years old. It may be considerably older. For 3 centuries, while every human being alive has lived and died, while every empire has risen and fallen, while all of recorded history since the Enlightenment has played out, a storm the size of Earth has been slowly turning in Jupiter's clouds.
At its largest historical size, the Great Red Spot was approximately 40,000 kilometers across. It has been shrinking in recent decades, and as of recent measurements, it is roughly 16,000 kilometers across, still larger than Earth, but considerably reduced from its peak. Scientists are not sure whether it will eventually dissipate or stabilize. It has been observed to maintain itself through interactions with smaller storms, occasionally absorbing them and drawing energy from them. The Great Red Spot is, in the language of fluid dynamics, a remarkably stable vortex, a self-maintaining structure that has persisted for centuries in a constantly churning atmosphere. Think of it rotating right now, as it has been rotating since before the invention of the steam engine, before the French Revolution, before the telescope itself. Turning, slowly, quietly, enormous, in the upper atmosphere of the largest planet in the solar system. Jupiter also has a remarkable family of moons. It has at present count 95 confirmed moons, more than any other planet. The 4 largest, discovered by Galileo in 1610, are called the Galilean moons: Io, Europa, Ganymede, and Callista. Ganymede is the largest moon in the solar system, larger than the planet Mercury, with its own magnetic field and a subsurface ocean of salt water. Europa has a surface of cracked ice over what is almost certainly a liquid water ocean,
heated by tidal flexing as Jupiter's gravity needs the Moon's interior. This ocean, which may contain twice as much water as all of Earth's oceans combined, is one of the most promising places in the solar system to look for life. Life, possibly, in the dark, warm water beneath kilometers of ice, on a moon orbiting a gas giant in the outer solar system.
But tonight we are not looking for life. We are simply appreciating the scale and the quiet. Jupiter, enormous and ancient, surrounded by its family of moons, each one in its own careful orbit, the great red spot turning, the cloud bands circling, the metallic hydrogen humming with electric current deep inside the planet, generating a magnetic field that stretches millions of kilometers into space, a vast invisible bubble protecting the inner solar system from cosmic radiation. Jupiter is a guardian in a gravitational sense. Its enormous mass attracts comets and asteroids that might otherwise be aimed at the inner solar system. It has absorbed enormous impacts throughout its history, the most famous being the comet Shoemaker-Levy 9 impact in 1994, when a fragmented comet crashed into Jupiter in a series of spectacular collisions. The scars were visible in Jupiter's atmosphere for months. Jupiter takes the hits so the inner planets do not have to. It is not a conscious act, not a choice. It is simply the consequence of being that large, that massive, that dominant in the gravitational landscape of the outer solar system. But the effect is real, and it has, over billions of years, made the inner solar system a safer place for small rocky planets and the life that might live on them. Section 9. Saturn, the most beautiful silence.
There is no other planet in the solar system that looks like Saturn. No other thing in the entire observable universe, as far as we know, that presents quite that particular combination of form. A golden, hazed sphere, larger than any description can adequately convey, wearing a system of rings that extend outward in a perfect flat disk, thin as paper relative to their enormous width, brilliant white and pale gold, and occasionally banded with shadow. Saturn does not look real. It looks like something someone designed, like a planet from a children's drawing wearing a crown. And yet there it is, 142 million kilometers away, actually there, actually like that, being that beautiful without any audience and without any apparent effort. Saturn is the second largest planet in the solar system. Its diameter at the equator is roughly 120,000 kilometers, about 9.5 times the diameter of Earth. Like Jupiter, it is a gas giant with no solid surface, composed primarily of hydrogen and helium. But Saturn is significantly less dense than Jupiter. In fact, Saturn is the least dense planet in the solar system. Its average density is lower than water, which means that if you had a bathtub large enough, Saturn would float. This is a fact that for some reason many people find either delightful or mildly disturbing, and both reactions seem entirely appropriate. The rings are the thing.
Saturn's rings are one of the most structurally intricate and beautiful features in the solar system. They extend from about 7,000 kilometers above Saturn's cloud tops to roughly 80,000 kilometers from the planet, covering an enormous area. But they are extraordinarily thin. On average, the rings are only about 10 meters thick. 10 meters. The rings span a distance greater than the distance from Earth to the Moon, and they are about as thick as a 2-story house. If you scaled the rings down to the size of a piece of paper, the paper would need to be about as wide as a sports stadium. They are composed primarily of water ice. Billions, possibly trillions of individual chunks of ice, ranging in size from microscopic frost particles to pieces as large as a house, each one orbiting Saturn independently on its own precise orbit. They do not touch, they do not communicate. Each tiny piece of ice is simply following its own gravitational path around Saturn, and together, in the aggregate, they create one of the most breathtaking structures in the solar system. A ring made of individual pieces of ice, each piece alone in its orbit, creating beauty collectively without any intention. The rings are organized into distinct bands, named with letters roughly in the order they were discovered. The main visible rings are called A, B, and C. Between the A and B rings, there is a gap called the Cassini division, about 3,500 kilometers wide and almost empty of particles. This gap is maintained by a gravitational resonance with Saturn's moon Mimas. Mimas, a small round moon with an enormous crater that makes it look unsettlingly like the Death Star from the Star Wars films, orbits Saturn in a period that is exactly half the orbital period of particles at the outer edge of the Cassini division. This 2-to-1 resonance repeatedly tugs particles out of that region, clearing it. The rings may be as old as the solar system itself, 4.5 billion years, or they may be considerably younger, perhaps as young as a few 100 million years. The question of their age is genuinely unsettled, and scientists continue to debate it. What is not debated is that they are there, and that they are made of ice, and that each piece of ice is moving in perfect gravitational silence around a planet that was already old when the first dinosaurs walked the Earth.
Saturn also has a remarkable moon called Titan. Titan is the second largest moon in the solar system, larger than the planet Mercury. It has a dense nitrogen atmosphere, thicker than Earth's. Its surface pressure is about 1.5 times Earth's surface pressure. It has weather, clouds, rain, lakes, and rivers. But instead of water, Titan's hydrological cycle uses methane. There are lakes and seas of liquid methane and ethane sitting on Titan's surface, filled not with water, but with cold, transparent hydrocarbons, reflecting the hazy golden light of a sun that appears as little more than a bright spot in the thick orange smog. The Huygens probe, which descended through Titan's atmosphere in January 2005, sent back sounds from its microphone as it fell. Wind sounds, like a recording made in a windstorm. The first sounds from another world. Another moon of Saturn, Enceladus, is a small icy world that ejects enormous plumes of water vapor from its south pole. These plumes contain water, ice particles, and organic molecules, erupting from a global subsurface ocean that is heated by tidal friction. The plumes are so substantial that they supply material to Saturn's faint outer E-ring. Enceladus is venting its interior into space, continuously, silently, throwing ice into Saturn's ring system from thousands of kilometers below. Saturn's magnetic field is peculiar. Unlike Earth's magnetic field, which is tilted relative to Earth's rotation axis, Saturn's magnetic field is almost perfectly aligned with its rotation axis. This is unusual and not fully explained. The planet completes a rotation in about 10.5 hours, slightly longer than Jupiter. And like Jupiter, its rapid rotation helps generate its magnetic field and causes it to bulge at the equator.
From Earth, Saturn is visible to the naked eye as a bright, slightly yellow star. With even a modest telescope, the rings become visible, and they are one of the most reliable shocks of beauty that amateur astronomy has to offer. People who see Saturn's rings through a telescope for the first time often cannot believe it is real. There is a very common report of people stepping back from the eyepiece and asking someone nearby to confirm that what they are seeing is actually the planet and not some trick of the equipment. Saturn is so extraordinary, so unlike anything in ordinary visual experience, that the brain sometimes refuses to believe it on first sight. It is there, though. It has always been there. It will be there tonight, rings catching the sun's light, ice particles orgasming in silence, a billion individual journeys that together make something so beautiful it looks invented. Section 10. Uranus and Neptune, the quiet ice giants. At the outer edge of the solar system's planetary zone, beyond Saturn's golden bands and ice-bright rings, there are two more worlds. They are different from the gas giants closer in, different in composition and character, and they are seldom the center of attention in any discussion of the solar system. They are far, they are cold, they are blue, and they are, in their own way, extraordinary.
Uranus is the seventh planet from the Sun, and it is different from every other planet in the solar system in one fundamental and immediately striking way. It is tilted on its side. Uranus's axial tilt is 97.77 degrees, where Earth is tilted at 23.5 degrees relative to its orbital plane. Uranus is tilted so far that its poles point almost directly at the Sun over the course of its 84-year orbit. For about 20 years of its orbit, one pole is in continuous sunlight, while the other is in continuous darkness. Then, as Uranus moves to the other side of its orbit, the situation reverses. The seasons on Uranus are extreme beyond anything we can intuitively grasp. The origin of this bizarre tilt is thought to be a massive collision with another large body early in the solar system's history. Something enormous struck Uranus and knocked it sideways, and it has been rolling around the Sun on its side ever since, every planet year for the past 4.5 billion years. The collision happened, the tilt remained, the planet adapted, in the sense that its weather patterns and magnetic field oriented themselves around this new geometry, and now rolling sideways is simply what Uranus does.
Uranus appears as a featureless pale blue-green disk in most images. Its color comes from methane in its upper atmosphere, which absorbs red light and reflects blue and green light. In Voyager 2's images, taken when the spacecraft flew past in January 1986, Uranus appeared as an almost perfectly smooth, featureless ball of pale blue-green, serene and unblemished, without the dramatic cloud bands of Jupiter or Saturn. Later, in the early 2000s, images from the Hubble Space Telescope revealed faint banding in the atmosphere and some storm activity, but Uranus remains the smoothest-looking planet in the solar system. Uranus has 27 known moons, all named after characters from the works of William Shakespeare and Alexander Pope. Miranda, Ariel, Umbriel, Titania and Oberon are the 5 largest. Miranda, the smallest and innermost of these, has terrain that is among the most varied and extreme of any moon in the solar system, including Verona Rupes, a cliff that drops approximately 20 kilometers, one of the tallest known cliffs in the solar system. Neptune is the 8th and outermost planet, and in some ways the opposite of Uranus in character. Where Uranus is featureless and calm-looking, Neptune is active. When Voyager 2 flew past Neptune in August 1989, it found a dynamic planet with enormous storm systems, including what was then called the Great Dark Spot, an anticyclone similar in some ways to Jupiter's Great Red Spot. Neptune has the fastest winds of any planet in the solar system, with speeds measured at more than 2,000 kilometers per hour.
These are winds blowing at close to 0.5% of the speed of sound on a planet so cold its surface cloud tops are around -210 degrees Celsius.
Neptune is about 17 times the mass of Earth. It is deep blue, a richer, darker blue than Uranus, from a different mix of methane and other compounds in its atmosphere. Triton, its largest moon, is one of the few large moons in the solar system that orbits in the retrograde direction, meaning it orbits Neptune in the opposite direction to Neptune's rotation. This suggests that Triton was not formed alongside Neptune, but was captured from the Kuiper Belt at some point in the distant past. Triton has geysers of nitrogen gas erupting from its surface. Dark streaks of nitrogen vented from the subsurface paint the pale pink surface of Triton with shadows. Even the most distant reaches of the solar system, it turns out, are geologically active. Neptune was predicted mathematically before it was observed. In the mid-19th century, astronomers studying the orbit of Uranus noticed small but persistent irregularities that could not be explained by the gravitational influence of the known planets. Urbain Le Verrier in France and John Couch Adams in England independently calculated where a previously unknown planet would need to be to cause those irregularities. Le Verrier sent his calculations to Johann Galle at the Berlin Observatory, and on the night of September 23, 1846, Galle pointed his telescope at the predicted position and found Neptune within 1 degree of where mathematics said it should be. Neptune discovered by equations. A planet found first in the mind, then in the sky. The universe has an orderliness, a mathematical precision that allows this kind of prediction. Knowing what is known, calculating what must follow, and finding it exactly where the numbers said. There is something deeply reassuring about that. The universe operates by rules, consistent, testable, reliable rules. And when you understand those rules well enough, you can find things that have never been seen simply by thinking carefully. Neptune takes approximately 165 Earth years to complete one orbit of the Sun. It was discovered in 1846. It has not yet completed a single orbit since its discovery. Every orbit of Neptune spans more than a human lifetime. Section 11. The Kuiper Belt and the Edge of Everything. Beyond Neptune, the solar system does not simply end. It continues, diffusing outward through regions of increasing cold and quiet, becoming less dense, less structured, more ancient and undisturbed, until eventually the Sun's influence fades into the general background of interstellar space. The Kuiper Belt begins at roughly 30 astronomical units from the Sun, just beyond Neptune's orbit, and extends to about 50 astronomical units. It is named after Gerard Kuiper, a Dutch-American astronomer who predicted its existence in 1951. The Kuiper Belt is in some ways similar to the asteroid belt between Mars and Jupiter, a region populated by small bodies left over from the formation of the solar system, but it is roughly 20 times as wide and 20 to 200 times as massive. Where the asteroid belt contains rocky and metallic objects, the Kuiper Belt is composed primarily of frozen materials, water, ice, ammonia and methane, reflecting the colder conditions in the outer solar system. Pluto sits in the Kuiper Belt. Pluto was discovered in 1930 by Clyde Tombaugh, a young astronomer at Lowell Observatory in Arizona, and was classified as the 9th planet until 2006, when the International Astronomical Union adopted a new definition of planet and reclassified it as a dwarf planet. This reclassification disappointed many people, particularly those who had grown up learning there were 9 planets,
and Pluto became something of a cultural touchstone for feelings about change and loss. But Pluto itself, indifferent to human classification schemes, continues to orbit the Sun on its long, slightly inclined, somewhat eccentric path, taking about 248 Earth years to complete one orbit. The New Horizons spacecraft flew past Pluto in July 2015, becoming the first and so far only mission to visit the dwarf planet. The images it returned were astonishing. Pluto was expected to be a dull, featureless ball of ice. Instead, it turned out to be a world of surprising geological complexity. There is a vast plain of nitrogen ice, roughly the size of Texas, that has been informally named Tombo Regio in honor of the planet's discoverer. This plain is divided into irregular polygonal cells, each hundreds of kilometers across, formed by convection currents in the nitrogen ice. The nitrogen is slowly, very slowly, circulating from the interior to the surface and back again, creating a slow, rhythmic overturning like a lava lamp, except made of nitrogen and operating at temperatures of minus 233 degrees Celsius and taking decades rather than seconds to complete each cycle.
Pluto also has mountains of water ice rising up to 3,500 meters above the plain, roughly comparable to the Rocky Mountains. Mountains of frozen water on a world so far from the Sun that the Sun appears as little more than a bright star in the sky. And Pluto has a thin atmosphere of nitrogen gas that expands when it is at perihelion, its closest approach to the Sun, and collapses back onto the surface as frost when it moves farther away. This atmospheric cycle operates over hundreds of years. Pluto's largest moon, Charon, is so large relative to Pluto that the two bodies are sometimes called a binary system rather than a planet and its moon. Charon is about half the diameter of Pluto, and the two orbit a common center of gravity that sits in the space between them. They always keep the same face pointed at each other, both tidally locked, rotating and orbiting in perfect synchrony. They circle each other once every 6.5 days, facing each other permanently, like two eyes that never look away. Beyond the Kuiper belt, even more distant, lies the Oort cloud. The Oort cloud is a theoretical, vast sphere of icy bodies surrounding the solar system at distances of up to 100,000 astronomical units, roughly a third of the distance to the nearest star. If the Kuiper belt is an outer suburb, the Oort cloud is the countryside surrounding the whole city. It is thought to contain trillions of icy bodies, the reservoir from which long-period comets are occasionally disturbed by gravitational interactions and sent falling inward toward the Sun on journeys that take thousands or even millions of years.
The heliopause is the boundary where the solar wind, streaming outward from the Sun, becomes too thin and too slow to push back the interstellar medium, the diffuse gas and dust between star systems. At the heliopause, the Sun's influence ends and interstellar space begins. Voyager 1 crossed the heliopause in August 2012, becoming the first human-made object to leave the solar system. It was roughly 11 billion miles from the Sun at that point, about 121 astronomical units. The edge of the solar system, if we define it as the heliopause, is approximately 11 billion miles away. If we define it as the outer edge of the Oort cloud, it may extend 1 or 2 light-years in every direction. The solar system is not a small thing. It is an enormous, ancient, slowly turning structure, and we are sitting near one end of it, on a small blue rock, warm and breathing, reading about the rest of it at night before sleep. Section 12. The Voyager probes, humanity's quiet messengers.
On the 5th of September 1977, a rocket launched from Cape Canaveral, Florida, and carried into space a probe called Voyager 1. 3 weeks earlier, on the 20th of August, its twin, Voyager 2, had been launched on a slightly different trajectory. Together, they began a journey that would last decades and cover distances that were, at the time of launch, barely conceivable.
Both spacecraft were designed to take advantage of a rare planetary alignment, one that occurs only once every 176 years, which would allow them to visit Jupiter, Saturn, Uranus and Neptune using gravitational slingshots to move from planet to planet without expending much propellant. The alignment was recognized in the 1960s by a graduate student named Gary Flandreau, who calculated that by launching in 1977, a spacecraft could visit all 4 outer planets in a single mission. Without this alignment, such a journey would have taken centuries. Voyager 1 reached Jupiter in March 1979. It found a world of extraordinary activity. Active volcanoes on Io, hints of a subsurface ocean on Europa, the complex banding of Jupiter's cloud layers. It flew on to Saturn, making its closest approach in November 1980, photographing the rings in breathtaking detail, discovering new moons, and revealing Titan's thick atmosphere. After Saturn, Voyager 1's trajectory took it upward out of the plane of the solar system, and it continued outward without visiting any more planets. Voyager 2, meanwhile, continued on to Uranus in 1986 and Neptune in 1989, the only spacecraft to have visited either world. It is still the only spacecraft to have done so. Both Voyager spacecraft are still operating, still sending data back to Earth, still in communication with NASA's Deep Space Network after more than 47 years in space. Voyager 1 is now, as of recent tracking, more than 23 billion kilometers from Earth, the most distant human-made object ever created. Its radio signals, traveling at the speed of light, take more than 21 hours to reach Earth. Each Voyager carries a golden record. The golden record is a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It was assembled under the direction of Carl Sagan, who described it as a bottle thrown into the cosmic ocean. The record contains 115 images encoded as analog signals. It contains greetings in 55 human languages and one greeting from the humpback whale. It contains 90 minutes of music from cultures around the world. It contains sounds of earth, wind and rain, surf on a shore, the murmur of a stream, the call of birds, the sounds of machinery, a mother's first words to a newborn child, footsteps, laughter. The record also contains a spoken greeting from Kurt Waldheim, then Secretary General of the United Nations, and a message from President Jimmy Carter that includes the line, "This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours." The chance that any other civilization will ever find the Voyager spacecraft and play the golden record is, by any reasonable calculation, extraordinarily small. The spacecraft are moving through an immense emptiness. They will travel for thousands of years before coming near another star system. In 40,000 years, Voyager 1 will come within about 1.5 light-years of the star Gliese 445. This is, in cosmic terms, a near miss, but not a visit. The spacecraft will drift past and then continue into the dark. And yet the record was made. The sounds of Earth were chosen and encoded and launched into space on 2 small craft. And even if no one ever plays them, they are out there. The first words a mother says to her child are traveling through interstellar space right now at the same speed as light, getting farther from Earth with every second, carried by a small machine that has been drifting quietly through the void for nearly half a century. There is something about the Voyager probes that touches something deep. Perhaps it is the scale of the journey, the improbable continuation of signal over such an incomprehensible distance. Perhaps it is the golden record, the gesture of reaching out into the dark with a message, not because it will certainly be received, but because it is the kind of thing that beings like us do. We reach out, we send messages, we want to be known, to say we were here, we heard music, we loved our children, we stood under the night sky and wondered. The golden record has been traveling for more than 47 years. It will outlast every institution and structure on Earth, long after every building that exists today has crumbled, long after the last human memory of Voyager's launch has faded. The spacecraft will still be drifting, the record still spinning slowly in the vacuum, carrying the sounds of an October morning, rain, birdsong, the laughter of a child, out into the patient dark. Section 13. The rhythm of orbits. Everything in its place. There is a piece of music hidden in the solar system.
Not music in the sense of melody or harmony, not something you could play on an instrument, but something with the same underlying quality, pattern, repetition, order emerging from simple rules. The planets orbit the Sun in ellipses, each one at its own distance and its own speed, each one completing its year in its own time. And these orbital periods have relationships with each other, resonances, coincidences of ratio, that give the solar system a mathematical structure of astonishing elegance. The simplest of these is the orbital resonance between Neptune and Pluto. Pluto completes exactly 2 orbits of the Sun for every 3 orbits Neptune completes. This 2-to-3 ratio is not coincidence. It is a stable gravitational relationship maintained over billions of years that keeps Pluto from ever coming too close to Neptune, despite the fact that Pluto's orbit crosses inside Neptune's orbit. The resonance ensures that whenever Pluto is at the part of its orbit closest to the Sun, Neptune is always far away on the other side. They have been dancing to this pattern for billions of years without coming close to each other. The 4 largest moons of Jupiter, the Galilean moons, have their own musical relationship. Io, Europa, and Ganymede are locked in a 1-to-2-to-4 resonance. For every 4 orbits Io completes, Europa completes 2 and Ganymede completes 1. This Laplace resonance, as it is called, is maintained by the same gravitational forces that produce the tidal heating inside Io and Europa, keeping their interiors warm and geologically active over billions of years. The music of their orbits is literally generating heat, keeping those moons from freezing solid, and possibly maintaining liquid oceans that might harbor life.
Johannes Kepler, the 17th century mathematician who first described the elliptical orbits of the planets, was convinced that the solar system was musical. He wrote about what he called the harmonices mundi, the harmony of the worlds, arguing that the orbital velocities of the planets at their closest and farthest points from the Sun were in ratios that could be expressed as musical intervals. he was not entirely wrong. The ratios he found were approximate rather than exact, but the underlying intuition that the solar system has a mathematical order that resembles the order of music was remarkably prescient. The planets have been orbiting the Sun for 4.5 billion years. 4.5 billion complete circuits, each one taking the same amount of time as the last, each one following the same elliptical path, each one governed by the same gravitational equations. Kepler found those equations, Newton explained them, Einstein refined them. And through all of this theoretical progress, the planets themselves simply kept orbiting, unconcerned with whether they had been understood. There is something stabilizing about imagining this, the clockwork solar system, not as a cold mechanical metaphor, but as a genuine expression of reliability. You will wake up tomorrow and the sun will rise, not because someone remembered to arrange it, not because a system is being maintained by someone, but because the Earth is on the same orbital path it has been on for 4.5 billion years. It will continue to rise every morning for as long as the sun continues to burn and the Earth continues to orbit, which is another 5 billion years.
The moon will pull the tides. Jupiter will bend comets from their paths. Saturn's rings will continue their silent, slow migration, particles drifting inward, settling eventually into the planet. Everything in the solar system is moving. Everything is changing. But all of it is changing at rates that human lives cannot perceive. On the time scale of a single night, of a single breath, of the slow weight of a body settling toward sleep, everything is still. The orbits hold, the patterns persist, the music, however you choose to hear it, plays on without interruption, steady and vast, and older than any word we have for old. There is a practical comfort in this too, beyond the philosophical. The reliability of orbits is what allows spacecraft to be sent to specific places at specific times, what allows scientists to know exactly where Jupiter will be on any given date decades in the future, what allowed the Voyager mission to be planned to intercept Jupiter in March 1979 and Saturn in November 1980. Trajectories calculated with such precision that the spacecraft arrived exactly where the mathematics said they would, on schedule, after journeys of hundreds of millions of kilometers. The orbits are trustworthy. The mathematics that describes them is accurate. The universe is, in this specific and practical and beautiful sense, completely reliable.
Every clear night, you could go outside and look up at a particular point in the sky and find Jupiter exactly where an app or a star chart or a century-old almanac says it will be. The mathematics works. It has always worked. The planets have never surprised an astronomer by being in the wrong place. They are always exactly where they are supposed to be. The same physics that governs the orbit of Jupiter governs the falling of rain and the turning of wheels and the movement of your own body as you shift in your bed and settle toward sleep. The universe does not have different rules for different scales. The same laws apply everywhere, to everything, always. Section 14. Sound, silence, and what space actually feels like. Space is silent. This is not a metaphor or a simplification. It is almost literally true.
Sound is a compression wave in a medium, and space is nearly a perfect vacuum. There are almost no molecules per cubic meter in the interplanetary medium, the region between planets. A sound wave cannot travel through space the way it travels through air, because there is no air for it to travel through. If you were to set off the loudest explosion imaginable in interplanetary space, the person standing 5 meters away from you would hear nothing. The silence of space is not like the silence of a quiet room, where there is still air around you, still the faint sounds of your own breathing and heartbeat. The silence of space is absolute in a way that has no analogue in ordinary human experience. It is the silence of vacuum. It is the silence of nothing. And yet,
NASA has produced recordings of sorts from space. Not recordings of sound waves, which do not exist out there, but translations of electromagnetic waves and plasma waves and magnetic field fluctuations into audio frequencies that human ears can perceive. These recordings, often called the sounds of space, are haunting and strange and beautiful. The sounds of Jupiter's magnetic field interactions with its moons are deep and resonant and shifting, like a whale singing in a cathedral that has no ceiling. The sounds of Saturn's radio emissions are strange, alien, rhythmic, something between static and music. Earth's own magnetic field produces sounds that have been described as something like choir music, high and soft and slowly shifting. The Sun, which is too far away for its actual sound to reach us, also produces waves. The surface of the Sun is in constant motion, churned by convection currents from the interior, and this motion produces oscillations in the Sun itself, standing waves that make the entire Sun ring like a bell. The study of these solar oscillations is called helioseismology, and by analyzing them, scientists can determine properties of the Sun's interior, the temperatures and densities and compositions of regions we can never directly observe. The Sun is ringing, faintly and continuously, with the equivalent of millions of different tones simultaneously. It has been ringing for 4.5 billion years.
If you could somehow translate the electromagnetic environment of the solar system into sound, what you will hear would not be silence. It would be a vast, deep, shifting hum. The magnetic field of Earth, the plasma waves in Jupiter's magnetosphere, the solar wind streaming past the planets, all of it generating electromagnetic variations that could, in principle, be translated into something that ears could interpret. A cosmic orchestra, playing in frequencies no human ear can detect, in a medium that carries no physical sound waves, in a silence that is, paradoxically, full of information. What would it actually feel like to be in the outer solar system, not on a spacecraft, but in some imagined, impossibly safe way, simply floating there? Near Earth, the Sun is a brilliant white light, far too bright to look at directly. By the time you reach Saturn, the Sun is about 1,000 times dimmer than it appears from Earth. It is still the brightest thing in the sky, still recognizable as a disk rather than a point, but it has lost its warmth. You could look at it directly if you were out there. From the distance of Pluto, more than 5 billion kilometers away, the Sun is simply a very bright star. Still the brightest by far, still visibly different from the other stars, but a star nonetheless, its disk too small to resolve with the naked eye. The temperature in interplanetary space, the temperature of the near vacuum itself, is approximately -270 degrees Celsius, about 3 degrees above absolute zero.
This is the temperature of the cosmic microwave background radiation, the afterglow of the Big Bang, which fills the entire universe with a faint, uniform warmth. The solar system sits inside this immense cold bath.
And yet, paradoxically, you would not necessarily feel cold in space, not immediately, because temperature in a vacuum is different from temperature in air. In air, heat is transferred from your body to the surrounding molecules by conduction. In a vacuum, there are no molecules, so there is no conductive heat loss. You would radiate heat slowly as infrared light, but this is a slow process. You would lose heat much more slowly in the vacuum of space than you would in cold air. What you would feel in those first moments might be something closer to stillness. No wind, no sound, the sun reduced to a brilliant point. The stars, unblurred by atmosphere, crisp and steady, and impossibly numerous. The stars do not twinkle in space. They are steady points of light, as crisp and still as holes in a curtain through which light falls. The twinkling we see from Earth is caused by the atmosphere, air of different temperatures and densities, bending and refracting starlight as it passes through. Without atmosphere, every star is a perfect, still, unblinking point. The sky from space is full of steady stars, and in the outer solar system, the Milky Way stretches across it in a broad, dense band, 100 billion stars visible without any atmospheric blurring, resolved into individual points of light, where from Earth it appears as a soft glow.
It is the most beautiful and the most humbling view available. Everything that has ever happened to any human being happened on a small piece of rock somewhere in the vast, quiet middle of this view. The wars and the love stories and the discoveries and the losses, all of it on that one small point of light, barely distinguishable from the others. And around you, in every direction, silence, ancient, complete, and, in its way, restful beyond measure. Section 15. The Stars That Made You. Before we close, there is one more thing worth knowing. One more fact, perhaps the most quietly astonishing of all the facts we have visited tonight. The atoms in your body were not always in your body. Most of the hydrogen in you, the hydrogen in the water molecules, in the organic compounds, in the hydrogen atoms that make up a significant fraction of every cell, was formed in the first 3 minutes after the Big Bang, nearly 14 billion years ago. That hydrogen has been in the universe for almost its entire history. It has been part of gas clouds and stars and planets and oceans and organisms for billions of years before it became part of you. Some of it may have traveled through multiple star systems before ending up here.
The heavier elements, the carbon, oxygen, nitrogen, iron, calcium, phosphorus, all the elements that make you specifically you, were forged in stars. Nuclear fusion in the cores of massive stars, burning for millions of years, fusing lighter elements into heavier ones. When those stars reached the end of their lives, they exploded as supernovae, scattering the elements they had created across the surrounding galaxy. Those scattered atoms drifted through space, perhaps for hundreds of millions of years, before being swept up by the gravity of a condensing cloud of gas and dust that would eventually become our solar system. Some went into the sun,
Some became planets. Some became asteroids. Some became the rocks that were eventually weathered into soil. Some became part of the first life on Earth. Some became part of the long chain of organisms that eventually produced, billions of years later, you. You are literally made of stardust. This is not a metaphor or a romantic saying. It is a description of nuclear physics and stellar evolution. The iron in your blood was created in the core of a dying star that exploded before our solar system existed. The calcium in your bones was scattered by a supernova billions of years ago. The oxygen you are breathing right now was fused in a stellar furnace and released into the interstellar medium long before Earth formed. Carl Sagan said it too, plainly and beautifully. We are a way for the cosmos to know itself, not separate from the universe, not visitors or observers from outside, but part of it, woven from the same materials, following the same physical laws, made of atoms that have been on an extraordinary journey through space and time before coming together, briefly and improbably, in the specific arrangement that is you.
The solar system is the neighborhood where this happened. The sun is the star that warms the planet where this arrangement of atoms became conscious. The other planets are the neighbors, going about their own ancient business, orbiting and cooling and accreting and doing what planets do. And out beyond all of them, the universe continues, older and larger and stranger than any mind can fully contain. You are part of this. You have always been part of this. Even before you were born, the atoms that would become you were in the solar system, drifting through the interplanetary medium or sitting in rocks or cycling through the biosphere. And someday, long after you are gone, those same atoms will continue. They will become part of something else, part of the Earth's chemistry, part of other organisms, part of a cycle that has no beginning and no end. This is not frightening. It is the most expansive and comforting thing there is. You are not outside the universe looking in. You are an expression of it, a brief and improbable and beautiful arrangement of ancient stardust, lying here tonight, breathing slowly, on a small spinning rock, in an ordinary solar system, in one of the outer arms of a galaxy so ordinary that most astronomers call it unremarkable. And yet, here you are. Let the sun's warmth, traveling 93 million miles in 8 minutes, find its way through memory and through the warmth of your bed. Let the moon hang where it always hangs, a little less than 400,000 kilometers above the curve of the Earth, pulling softly on the oceans, slowly drifting away. Let Mercury sit in its long, slow day, its cratered plains turn toward the black sky. Let Venus turn backward in its thick golden clouds. Let Mars cool in its thin twilight air, the butterscotch sky deepening toward night. Let the asteroid belt be empty and quiet, a handful of ancient rocks in an enormous wilderness of space. Let Jupiter's great red spot turn, as it has been turning for 350 years or more, without drama, without urgency. A storm the size of Earth, slowly circling above the cloud tops of the largest planet in the solar system. Let Saturn's rings drift in silence, billions of pieces of ice on their individual orbits, each one a separate journey, together making something so beautiful that people step back from their telescopes in disbelief. Let Titan breathe its methane air under its orange haze. Let Enceladus vent its plumes of icy water into the dark above Saturn's south pole. Let Uranus roll sideways through its long year, and let Neptune spin in the blue-black cold of the outer solar system, its winds the fastest of any planet, its voice unheard in the vacuum. Let Pluto turn its ice-white plains toward a distant sun, its heart-shaped nitrogen plains slowly convecting, a cold geological process playing out in the deep freeze of the outer solar system.
Let the Voyager probes drift onward, carrying their golden records into the interstellar dark, the sounds of Earth growing ever more distant from the Earth itself. Let the solar wind push outward in all directions, a slow breath from the sun spreading through the entire system, reaching the heliopause and fading into the general background of interstellar space. And in the middle of all this, on a small blue world in the inner solar system, you are lying in your bed. Your planet is doing its job. It is spinning at precisely the rate it has always spun. It is orbiting the sun on precisely the path it has always followed. The air above you is being held in place by precisely the gravity that has always held it. The moon is following its orbit, the tides are moving, the seasons are in their proper sequence. Everything is exactly as it should be, and has been for as long as there has been an Earth to be anything at all. You do not need to do anything. There is nothing to manage tonight, nothing to check or fix or decide or prepare. The planets are in their orbits. The sun is burning steadily. The stars that made you billions of years ago have already done their work. The atoms that are you have been on an extraordinary journey through space and time, and right now, tonight, they are here, in this specific arrangement, in this specific place, breathing slowly, warm and quiet.
Let the scale of it hold you, not press on you, not overwhelm you, but hold you, the way the earth holds you, with gentle and irresistible gravity, the way the solar system holds the earth, the way the sun holds everything, all of it just staying in its place, all of it moving and yet so perfectly ordered that from where you lie it feels like stillness. The universe is 4.5 billion years old in this neighborhood. The sun will burn for 5 billion more. You are here for a small fraction of that, a brief visit, an improbable arrangement of stardust that somehow became capable of looking up at the night sky and asking questions. That is remarkable. That is, by any measure, extraordinary. Tonight you do not have to ask questions. Tonight you just have to breathe. Let your eyes rest. Let your thoughts slow, the way the planets slow as they move outward, from the quick inner orbits to the long, quiet journeys of the outer worlds.
You have been on a long journey today, through all the small ordinary urgencies that fill a day. Let it all drift now, the way Mercury drifts in its slow rotation, the way Pluto drifts in its 248-year orbit, the way the Voyager probes drift in the patient dark.
You are somewhere in a solar system that is somewhere in a galaxy that is somewhere in a universe that is 14 billion years old and still expanding, still growing, still making room. You are a small, specific, temporary, irreplaceable part of all of it. You have been held in the gravity of this star for all the days of your life, without ever falling off, without the orbit failing, without the sun going out or the air disappearing. You are safe tonight. You are exactly where you are supposed to be. The solar system will keep doing what it does. The sun will keep burning. The planets will keep orbiting. The ice in Saturn's rings will keep circling in its perfect silent paths. And you can sleep.
Before you do, carry this with you into the quiet. Every civilization that has ever existed has looked up at the same solar system. The ancient Egyptians watched Venus rise before the sun in the pre-dawn sky and called it a star of crossing. The Babylonians tracked Jupiter through the constellations and used its position to make predictions about kings and harvests and the outcomes of wars. The Maya built their entire calendar system partly around the cycles of Venus, which they observed so carefully that their predictions of Venus's appearances were accurate to within a few minutes over centuries. The ancient Greeks understood that the Earth was round, calculated its circumference, and correctly guessed that the Sun was much larger than the Earth. The Chinese recorded sunspots more than 2,000 years ago, dark spots on the face of the Sun visible to the naked eye at sunrise and sunset, blemishes on the surface of the star they were watching with the same eyes, looking at the same sun that you can see from your window. Copernicus rearranged the solar system in 1543, moving the Earth from the center and placing the sun there instead. Galileo pointed a telescope at Jupiter in 1610 and watched 4 small points of light shift position from night to night, understanding that they were moons orbiting Jupiter and not Earth, one of the first direct proofs that not everything in the solar system revolved around us. Newton explained why the planets moved in the paths they did, working out the mathematics of gravity in the same years that he was also inventing calculus, which he needed to do the calculation. Herschel discovered Uranus in 1781, the first planet found with a telescope, the first expansion of the known solar system in all of recorded history. Adams and Leverrier found Neptune with mathematics alone, as we described, predicting the existence of a world no one had ever seen. And then there was the 20th century. Pluto discovered in 1930. The space age beginning in 1957 with the launch of Sputnik, the first moon landings, Voyager and Pioneer, the Hubble Space Telescope, Mars Pathfinder, Sojourner, Spirit, Opportunity, Curiosity, Perseverance, Cassini at Saturn, New Horizons at Pluto, Messenger at Mercury, Juno orbiting Jupiter, each one a small machine sent from our planet to go and look at another part of the solar system, to take pictures and measure things and send the data back home across the emptiness. And through all of it, the solar system itself remained exactly as it had always been. The sun burning, the planets orbiting, the moons circling,
indifferent to whether they were being observed, indifferent to whether they were understood, simply there, doing what they do, as they have done for 4.5 billion years, as they will continue to do long after every telescope ever built has ceased to function, long after every hard drive carrying every photograph ever taken of the planets has degraded into unreadable noise. The solar system does not need us to watch it, but we need to watch it. We need to look up. We need to know that we are part of something vast and old and beautiful. We need the perspective. The overview effect that astronauts describe from space is available to all of us in a less dramatic form, simply by learning these things, by knowing how far away Saturn is and what its rings are made of, by knowing that the Sun has been burning for 4.5 billion years and will burn for 5 billion more, by knowing that Voyager 1, launched the same year that Elvis Presley died, is now more than 23 billion kilometers away and still sending home data. You can sleep now. If these slow journeys through the quiet places of history and science help your nights feel a little more restful, a little more peaceful, please consider leaving a like on this video and subscribing to the channel. I have been making these videos for over a year, pouring care into every word, and I am still somewhere around 200 subscribers, trying to reach 1,000. Every single subscriber means the world to me. Every comment from someone who says a video helped them sleep on a difficult night is why I keep doing this. Thank you for being here. Thank you for listening. Sleep well wherever you are. The universe has you.